Hello guys, welcome back to Maison African Motives, still on our mathematics for grade 10. Remember previously we worked with our trigonometry, working from the trigonometric ratios, and we also saw the application of our Pythagoras theorem again as a revision. So in this case, what actually are we going to be focusing with is an extension that we are going to be having from those trigonometric ratios that we considered. So this one, we are just going to have an extension that is an extended part. We are going to extend from there, but focusing on what we refer to as the Cartesian plane. So we want to see how our angles are going to be taken. As you can see, there are so many presentations of these angles. So you need to know your Cartesian plane so that you understand how your angles are going to be taken and how do you calculate a certain trigonometric ratio from another trigonometric ratio, because you have your quadrants and you also understand your Pythagoras theorem. So we are going to start with an application of our Cartesian plane in this case. What is it that we are actually referring to, and how exactly are we going to refer our angles on our Cartesian plane? Referring to a Cartesian plane, we basically understand this when we are drawing our graphs, where we just refer to the x-axis and the y-axis. This is the major part that we just know, or that we understand about this Cartesian plane. But here we are going to have an extension of this Cartesian plane referring to angles and how are they going to be taken. All right, considering as part of our syllabus, focusing or working with positive angles. But as you move on, you're going to be focusing with negative angles. So in this case, we are focusing with positive angles. So it follows that in order for you to take these angles that you are going to have in each quadrant, you are going to take them in the anti-clockwise direction. So you're going to be referring to your angles in the anti-clockwise direction. So you're going to see that the angle at the starting point here is going to be 0 degrees, because you're starting from here going in this direction, and they will be positive. So these angles, they are actually divided from the 360 degrees of a complete revolution, which gives us 360 degrees. We are dividing into 4 equal quadrants. So if we do that, we divide 360 degrees by 4, you're going to obtain 90 degrees. So it means these quadrants, they are separated from each other by an angle of 90 degrees because they are equal. So here we are going to have 90 degrees. We add, because it's separated again by another 90 degrees. So 90 plus 90 is going to give us 180 degrees. 180 degrees plus 90 again, which is going to give us 270 degrees. 270 degrees plus 90 again, which is going to give us 360. We are back to the point of 0. So the point of 0 and the point of 360, they are just the same, meaning to say they give us the same values or the same indication in terms of our ratios, whether it is the ratio of cos or we are talking about the sine. We are going to have same values at this point. We are referring to that as our reference point, where we are starting, going in the anti-clockwise direction, taking our angles as positive. All right, so with this quadrant that I am indicating here, you are going to see that in each and every quadrant, there is a reference angle that can be taken from there. All right, what am I actually saying? If you are given your Cartesian plane, it follows that in each and every quadrant that you're going to have, you can present in form of a right angle triangle representing the x values and the y values. All right, let's say I have got a point taken from the origin to another point, which is referred to as P, which is my terminal point in that case. Having the coordinates, remember a point on a Cartesian plane. Let's say I want to represent the point P on a Cartesian plane. It is represented with the x value followed by the y value. So this is the use of our Cartesian plane. We are saying that it is taken from the x value and the y value. And in this quadrant where we are having our line or where we are having our P is the first quadrant where this X is positive and the Y is positive. It follows that since we are going to the right side, remember from your number line, if we are going to the right, these values, they are taken as positive values. So these values are taken as positive. This X will be negative. This Y on top will be positive. This Y below will be negative. So we are representing the point P in the first quadrant where these are positive. All right. So if we are to consider this as X followed by Y like this, it means that we are going to take the X value corresponding to this point. If you are to check here, this is going to correspond. If we take it down to the X-axis, it is going to correspond here. So meaning to say this value corresponding is the X value. And if you go with this direct to the Y-axis, the value that you're going to have there is the value of the Y-axis. So what does it mean? It simply means the distance from this point to the Y-axis here is the same as the distance that I'm going to have on this line here. So if this is the value of Y, which is positive, it is the same value of Y that I'm going to have here as a positive. If this distance represent X, it means I'm going to have my X in this case and being what? And being a positive, and this will form a right-angled triangle at the end. And this side that we have is our hypotenuse, which is referred as R as the resultant. So as we know, guys, that from our calculation, we say that the hypotenuse squared is equal to A squared plus B squared, whereby this C is representing, or we are talking about the hypotenuse in that case. So in this case, our hypotenuse is represented as R, which is the opposite or the one that faces the 90 degrees. So we're going to say that the formula for calculating this side R is going to be taken as R squared is equal to A and B being the shorter sides. So we are now referring to them in terms of X and in terms of Y because of our Cartesian plane. We've got X and Y. So it is going to be given as X squared plus Y squared like that. So that means from this formula, simply on the Pythagoras theorem, and we know that Pythagoras theorem is used to calculate the sides. So meaning to say, I can calculate the sides from that formula. And now because it's on a Cartesian plane, we can have a condition of having negative values. Remember, I was saying if you're just given a normal triangle like that, your values, they are all taken as positive. But now on a Cartesian plane, because we have the negative side and positive, it means also we can have negative values. The only value that cannot be negative is this resultant, which is the hypotenuse. R is always positive. So R is always, all right? So R is always positive in that case, all right? That is the hypotenuse. We cannot have our hypotenuse as a negative value, all right? So being in the first quadrant, referring to the point P that gave us this triangle, and now we talked about R and how do you calculate that R? You have the value of R. You can find any trigonometrical ratio in this quadrant referring to the angle theta taken from the, remember I said our angles, they are taken in the anti-clockwise direction. So the angle theta taken from this point up to this point is going to be referred, we can just refer that angle as theta. So remember from our trigonometrical ratios, we referred that we can have the condition of our SOHCAHTOA concept, right? So we've got the condition of the SOHCAHTOA concept. We have got the ratio of sine being opposite over hypotenuse, adjacent over the hypotenuse, for cos, for tan, opposite over the adjacent. It means we can have this in terms of X and in terms of Y from what we are given on this diagram. So what it simply means is that I can have the value of sine theta, which is referred to as the opposite over the hypotenuse. And according to this triangle, according to this theta, this is our opposite, this is our hypotenuse, and this is our adjacent. So you can see that the sine of theta is going to be taken as the opposite, which is positive y in that case, over the hypotenuse, which is r. So we are going to have a positive over a positive there. We refer to the cosine of theta, which is adjacent over the hypotenuse, adjacent being a positive, that is positive x, over the hypotenuse being a positive, so it is going to be x over r, which is being a positive. Then again, we talk about the tan of theta in the same quadrant. We are going to see that the tan of theta is going to be taken as the opposite over the adjacent, that is the opposite being a positive y in that case over x, which is being a positive, that being a positive x. We're going to have this as positive y over x, opposite over the adjacent. So we are going to see that in this quadrant, which is our first quadrant, whatever trigonometrical ratio that you are going to obtain, it is going to be positive. Everything that you have in this quadrant is going to be a positive. Everything that you're going to obtain in this quadrant is going to be given as a positive. So it is going to follow that because the theta, and also the other thing that you're going to consider, if you are in the first quadrant, it follows also the angle that you are working with. It's on a condition, because remember what I said about our angles. In between here, we said it's 0 and this is 90 degrees. So if I want to talk about the first quadrant, I can refer this as the first quadrant, which is fine, or I can refer to a condition where I am saying cos is positive, tan is positive at the same time. It is the only quadrant where all the ratios can be positive at the same time. This is the only quadrant where the two ratios that you are given, or all the three ratios, they are positive. There is no way that we are going to have a quadrant like in this quadrant. We cannot have two of the trigonometrical ratios being positive. It's only one that is going to be positive. Also in this quadrant, you are going to see that it is only one ratio which is going to be positive also in this. So it is only in the first quadrant where you see the two being positive or all of three being positive. So whenever you are given, I'm saying when you are answering questions, you are given two of them, they are positive. So it means that you are in the first quadrant. Or another thing that you can be sure about, that you are in the first quadrant, it is the indication of the angle that you are given. Our angles in the first quadrant, they range from theta, which is 0 degrees, up to 90 degrees. In between, it cannot be 0. Our angle cannot be 0. All right, the other thing, it cannot be 90, because at 90 degrees, we are now talking about a right angle. So our angles, they are supposed to be in between. So that is where you are given these intervals like this, 0 is greater. You are given a condition of your theta being in the first quadrant where it is taken in between, but at 0, we are not having like any point, any movement there. At 90 degrees, it will be a right angle. But these are the limits or the boundaries that are govern or that limit our first quadrant from 0 up to 90 degrees. So we are going to have, or we are going to indicate this as a condition where theta in that case will be greater than or equal to 0 degrees, but less than or equal to 90 degrees. Our theta is going to be greater than this value or equal, but less than or equal to. But in a normal condition, our theta is supposed to be greater than, because it cannot be equal to 90 degrees, because at 90 degrees, that's a right angle. But like I said, these are the boundaries, the limits of our theta in the first quadrant, all right, in this quadrant, all right. If you move on to this quadrant between 90 degrees and 180 degrees, between 90 and 180, you are now in this quadrant here, which is your second quadrant. So you name your quadrants because of the direction. Like I said, you are moving in the anti-clockwise direction. So you name your quadrants as the first quadrant, all right, the second quadrant, the third quadrant, and the fourth quadrant, like quad 4 equal. Okay, they are just equal. sectors that we take of a circle. So that's we are referring as the first, second, third. So in this second quadrant, which is between 90 degrees and 180 degrees, we are going to see that these answers, they are going to be different, right, in terms of the signs that we are going to have. Okay, let us see what I'm trying to say. Let us say we are indicating for an angle theta. So let us just say this is our first condition. Then we've got the second condition whereby we are in the second quadrant in that case. All right, you are in the second quadrant, and I said in that quadrant, that is the condition where theta, remember this is 0 degrees, 90 degrees, 180 degrees. You are now talking from 90 to 180 degrees. So your theta is going to be greater or equal to 90 degrees less or equal to 108. This will be the boundaries of your theta, but it's supposed to be greater than 90 but less than 180. Because 108, we are now talking about a straight line. 90 degrees, we're talking about a right angle there. So the boundaries are supposed to be greater than 90 but less than 180. So here I'm just giving to say, where is it starting from? It is starting from 90, ending up at what? At 180 degrees. This is the quadrant that we are referring to. In this quadrant, we are going to see that our terminal point is going to be like this. We are going to have it at the end like that. So we are going to have our point like this. All right, let us just have a sketch just like the previous case, but this time we are going to notice some differences here. Let us see what will be the differences. Remember, this is x and y here. So we're going to have our point O. Let's say this is where we have our point P at the end, which gives us the value of x and the value of y. But as you are to note now, at this side here, our x is now a negative. Remember, I said at this side, x is negative. So we are going to have our point x is no longer positive, but it is now a negative. The y value is on top, and on top, y is a positive. So meaning to say, we are going to have the y value as a positive. So this is the indication that you are going to have in the second quadrant. X is now a negative. We are in the negative side. So meaning to say, we are going to have negative x, y here being a positive, all right? So y is going to be a positive. Then, like I said, given the value of x and the value of y, you can use these values to determine or to find the value of r in this case from this formula of our Pythagoras theorem. Then you determine your r there. So they can indicate now theta, because our theta is now an angle that is greater. We are now talking about the whole of this angle up to the point here. This is the one that you are given as your theta. But what you're going to do, because this theta, it is, okay, take note what is happening. We are taking this theta into a right-angled triangle for our calculation. As we are calculating our ratios, we are using the angle that is inside this one, representing this theta, but we are taking it from the inner part of our ratios, because remember, from our ratios, we need to know which side is the opposite. So the angles, they are taken, the sides, they are taken according to this angle that we have here, which is actually your reference angle. But you are indicating your ratios in terms of theta. Do not confuse this. You are representing your angles in terms of theta, but taking your ratios from this angle here, which is not theta, which is actually 180 degrees minus theta, because you are saying these angles at this point, remember, this is 90, this is 180. So at this point, we've got 180. So it is going to be 180 minus this angle. But that one is not important. Like I said, you are going to take your answers in terms of the sine theta to say what is the value of sine theta, but you are using this angle inside of the triangle, this one, inside of the triangle, all right? So as we saw, guys, from our ratios, all right, I wrote our ratios somewhere here. Sine, we said, is opposite over the hypotenuse in that case, all right? Okay, let us just name our sides. Remember, according to this angle, this side is the opposite. So we are going to have the opposite here. This is your adjacent. the one where the angle and the 90 degrees are found, and this is your hypotenuse in that case. All right, so like I said, the sine theta is the opposite over the hypotenuse in this case. We are going to see that the opposite according to this theta is positive y. All right, so we've got positive y over r in this case, which is the hypotenuse. So it's going to be a positive value. All right, let's move on to cos theta and see what's going to happen with cos theta. All right, the cosine of theta is given, remember guys, from our SOHCAHTOA concept, cos is adjacent over the hypotenuse, which is adjacent over the hypotenuse. And our adjacent is a negative there. So it is going to be negative x over the hypotenuse, adjacent over the hypotenuse. All right, let's see the tan of theta. The tan of theta is the opposite over the adjacent. Opposite over the adjacent. The opposite, it's positive y in this case, but the adjacent is negative x. So this is what I was explaining before to say. It only happened in the first quadrant where all of the ratios, they are positive. Once you move from these quadrants, you are going to see a change. There will be only one trigonometrical ratio, which is going to be a positive. In this quadrant or in this region, from 90 to 180 degrees, it is only sine which is positive. Only sine which is positive. Cos is a negative value, tan is a negative value. It is only a tan which is positive. So you are going to see that happening in each and every quadrant. So I want you to fill in up to the last part, but I'm just going to give you a rough sketch of what's going to happen. Then you fill in, you finish up this part and see how your ratios are going to be given. Then I'm going to just give you a conclusion at the end. So in the third quadrant, you are going to see that the angles, remember, this is 180 degrees, this is 270 degrees. So we are starting from 180. So our theta is greater than 180 degrees, less than or equal to 270 degrees. So from the point of our origin to the terminal point, maybe this is our P in this case. You're going to see that in this quadrant, your X values are this side. These are your X values. And this side, the X values, they are negative. All right. The Y values are down here. And I say down below the X-axis, your Y values, they are negative. So you're going to see that your Y values, they are in the negative. So how do you complete your triangle? Your triangle is going to be taken like this, right? You are going to have the point P as a negative value for X and a negative value for Y in that case, meaning to say X is in the negative, is on the negative side, Y is going to be on the negative side. And this is going to be your R, which is your hypotenuse. So I want you to find out your ratios, but in this quadrant, you are going to see that it is the tan of theta that is going to be a positive. It is the tan of theta that is going to be a positive. So I want you to finish up, find your ratios and see if truly what I'm saying is the truth, that the tan of theta there is going to be a positive. Then you move on to the last quadrant, which is your fourth quadrant. All right, so this was your theta there. The fourth quadrant, I'm just going to give you a rough sketch of what you're going to do. Then you fill in and you find your ratios just like all the other examples that I was showing you guys. So you're going to see that in the fourth quadrant, we are now talking about this condition whereby I've got 0 to the terminal point. Maybe this is our P there. And in this quadrant, as we check, the X values are this side where they are positive. The Y values, they are down here where they are negative. So we are going to see a condition that the point P, X is going to be a positive value, and the Y values, they are going to be a negative. All right, so that means we have got our X this side being a positive, having our 90 degrees here. These are the Y values being a negative. You find the value of R, which is the hypotenuse, and the theta, like I said, always taken from the positive horizontal axis going in the anti-clockwise direction. So this is the angle that you're going to take up to this point that you're going to be referring as theta. And this angle that we are referring as theta is an angle that is going to be greater than 270 but less than 360. Remember, this is 270 degrees. This is now 360 degrees. So theta is going to be greater or equal to 270 but less or equal to 360 degrees. That is in the fourth quadrant. That is what you're going to have. And if you are to check, or if you are to find your trigonometrical ratios, just like the previous case, you are going to see that only the cos of theta in this quadrant is going to be a positive. All other ratios, they are going to be taken as negative. So I want us to now conclude this with questions. You are going to see that at the end, we can conclude using this because we saw that in the first quadrant, all right, this is what we had here. In the first quadrant, it's sine, which is, in the first quadrant, all of these ratios, they are positive, all right. In the second quadrant here, we saw that it's only sine which remained a positive. All others, they are negative. In the third quadrant, I explained that you're going to see that it is a tan which is going to be positive in that quadrant. And in the fourth quadrant, you are going to see your cos being a positive. So you can conclude to say that from all this whole thing that we are talking about, we can use the cast concept to have our indication of angles. But using the cast, you're going to start in this quadrant. It's going to be cast like this. What does it mean, this cast? It means that all, which is A, from the first quadrant, which is from 0 to 90 degrees in the first quadrant, all of the trigonometrical ratios, they are going to be positive. All the sign that you see represents the one that is positive there. So A is for all. So all ratios, all trigonometrical ratios in this case are positive, all of them. That is why we saw sine was positive, cos was positive, tan was positive. But in the second quadrant, which is this quadrant, from 90 degrees to 180 degrees, we are going to see that it's only sine. This S is for sine. So it concludes that it's only sine being positive. So it's only sine being positive. What does it mean? Cos is going to be a negative, tan is going to be a negative. All right. And the third quadrant, the ratio, this one, T is for tan. So from 180 degrees up to 270 degrees, you're going to see that it's only tan which is positive, just like what I explained there. So you're going to see that only tan is positive. So what is going to happen with sine? It is going to be a negative. What about cos? It is going to be a negative. And in the fourth quadrant, which is our last quadrant, I said it is the cos which is positive, and it is exactly what we see here from the cast concept. The C that represents cos. So it's only cos which is a positive in this case. So what does it mean? It means sine is going to be a negative, tan is going to be a negative in that quadrant. So there is no quadrant that all ratios are going to be positive except for the first quadrant. That is, all ratios are positive. So you are supposed to know what does it mean. And what it means if we are saying a ratio is positive. If I'm saying cos theta is positive, it means cos theta is greater than 0. That's cos theta is positive. If I want to say cos theta is a negative, I can also present this as cos theta is less than 0. Cos theta is less than 0, as we know that values that are less than 0 are negative values. Positive values are values that are greater than 0. So it can be another way that they can present to you. So they can present a condition. Maybe they are saying tan theta is positive and cos theta is less than 0. They are simply saying cos theta is a negative. So you are supposed to locate a quadrant where you find both these conditions satisfied. Like, where do we have tan being a positive and a cos being a negative? we can see that from our quadrants, the only quadrant that tan can be positive is here and cos being a negative. So they are talking about from 180 to 270 degrees. So you are supposed to have the knowledge of your angles because they can represent your angles in this way. Your trigonometrical ratios, I mean, in that way, that it is less than this or it is greater than this, you are supposed to know every concept. All right. So anyways, let us see how are we going to apply this information, all of this information. And other thing that you are supposed to also take into consideration is that if I am representing an angle like this, angles that are being squared, we shall also talk about that as we move on. But if you represent an angle, let's say I want to represent the sine squared of theta like that, the sine squared of theta like this, it simply means the sine of theta like this squared, right? The whole of this is being squared, not to write it as sine theta squared. This is now wrong, all right? So this we shall talk about it as we revise our questions. So let us check our questions. Exercise 8, we are given if the sine of theta is 3/5 and theta is taken from 0 to 90, determined by means of a diagram these values. All right. Take note, we are given a ratio of sine theta, which is 3/5. Why are they giving us an interval of theta that theta must be taken from 0 to 90? Because if you check from your Cartesian plan, the sine theta can be given as a positive in two quadrants. You're going to see two quadrants where sine is a positive. All right, let us go back to our diagram concept and see how we can present this. All right, so here we are given that the sine of theta is given as 3/5. All right, so like I said, from our quadrants, we are told that if we check from this Cartesian plan, we are going to see that where we have a condition where theta is greater than 0 degrees but less than 90 is in the second quadrant, right? In the first quadrant, 0 to 90, that's the first quadrant. Remember, this is 0 degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees, this is 360 degrees. So there they are giving us a condition where theta is in between 0 and 90. In between 0 and 90, that means we are in the first quadrant. We are in the first quadrant. And remember our presentation, what I indicated previously, what does this part really represents? All right, so if we are to consider in the first quadrant, we are going to have something of this nature. The theta is the angle that you are going to have from this point up to the line. So this is our angle theta. So our diagram at the end is going to be a right angle triangle, which is going to be filled in with the information that you have about this sine of theta here that you are given. Remember that from our trigonometrical ratios, the ratios, guys, they do not end. We still have those in our mind, the SOHCAHTOA concept. All right, so remember from our trigonometrical ratios, from our SOHCAHTOA, we are going to see that the sine of theta is opposite over the hypotenuse. So what it means is that on this ratio, this 3 that we see is representing the opposite, and the 5 that we see is representing the hypotenuse in this case. All right, so we have got the opposite and the hypotenuse. All right, so let us fill in our diagram according to theta. Remember, theta represents the sides that you're given. So according to this theta here, this is our opposite side, this is our adjacent, all right, whereby the hypotenuse does not change in this case, which is our r. So we are going to see that the opposite, which is 3, so this is our opposite here, which is 3, the hypotenuse, which is 5. So our hypotenuse in this case, this is our 5, which we said the hypotenuse is given by r. So it means r is equal to 5. The 3 that we see here is for the y value. Remember, this is y and these are the x values. So this 3 that we see is for the y values. The 5 is r there. So we are supposed to calculate the value of x, which is from this point up to this point. what is going to be the value of x. So where are we going to obtain the value of x? That's where we are back to the Pythagoras theorem, because we have got two sides that we are given. So including or working with two sides, the best way to use or to apply is to use our Pythagoras theorem. But like I said, the hypotenuse this time is given as r. So it follows that r squared is equal to, that is the hypotenuse squared, is equal to the square of the shorter sides. We are talking about the x values in the x-axis. So this is going to be x squared plus the y values, which we are given as what? As 3. So that will be x squared plus y squared. So there we're going to substitute r squared, that is 5. So we are going to have 5 squared is equal to x is the one that we are supposed to calculate here. So we are going to have this as x squared plus y squared, the value of y there, which is what? 3. So that is 3 squared. 5 squared, that is 25, is equal to x squared plus 3 squared, which is 9. So we can find the value of x by transposing 9 to the other side, so that we can subtract. This will be 25 minus 9 like that, which is going to give you a 16 at the end. So that 16 is equal to x squared. So to have the value of x, you can just introduce the square root both sides. But like I said, now you are working on the Cartesian plane, where our values can be positive and negative. So the first thing is for you to write plus or minus to represent the square root of the number. So the square root of 16, which is plus or minus 4, is equal to x. But as a conclusion, we can see that where our x is located according to our diagram, this is our x-axis. So according to our x-axis, our positive values are this side and our negative values are that side. Like I explained, this is positive, this is negative. So according to our triangle, as we can see, we need to be focusing on this side of the Cartesian plane, where x there is a positive. So therefore, our x, we are going to take it as a positive value, which is a positive 4 in this case, not a negative. So meaning to say here, we are having a 4. Why are we calculating this side? Because whatever ratio that you are going to be given to calculate, it is going to be focused on this triangle. You are going to focus on this triangle. And for it to be a complete, it must have all the sides, so that you can be able to calculate for whatever given ratio. You must have a complete triangle in terms of the sides. That means you can be able to calculate whatever ratio that you are given. The first question was to calculate the value of cos squared theta from this triangle that we have. Now we've got all the information that we need, like everything on our diagram. So what is going to be the value of cos squared theta in this case? All right. So remember what I mentioned before, that when you are dealing with a squared like this, a square, it means the cos squared of theta means the cos of theta squared, like this. So what we can simply have in shorter terms is that a trigonometrical ratio maybe is the cosine to the exponent of any theta, like this. It means the cosine of theta to the exponent of n. All right, that's how you can present this for a trigonometric ratio. So meaning to say, if I can be able to find the value of cos theta, I'm just going to square that value. And I know that the value of cos theta is obtained from adjacent over the hypotenuse. So I'm going to simply substitute. That means the value of cos squared theta is going to be the adjacent over the hypotenuse. But your answer for that, you must be able to square your answer. All right. So according to our formula, the adjacent, which is 4 in this case, over the hypotenuse, which is 5 in this case. So we are going to have 4 over 5, everything to the exponent of 2. So this is going to give us the value of cos squared theta, which is 4 squared is 16 over 5 squared, which is 25. Or you can just use your calculator in that manner. We can just have our calculator for our simplification. Just open your bracket, insert 4 over 5, that is 4 over 5 like this. So everything is going to be squared like this, which is going to give us 16 over 25. So that is how we can have our values calculated in that manner. All right, so as you can see, once you've got a complete diagram, it will be easier for you to calculate whatever that you want to calculate because your diagram is complete. And let us move on to number 2, which is 2 tan theta in this case. All right, so there we are supposed to calculate the value of 2 tan of theta. So it's just a substitution that we are simply having because already we have everything on this diagram, and the tan of theta, which is the opposite over the adjacent. So it is going to be 2 times, according to the theta, the opposite in this case is 3. According to our theta, the opposite is 3. So that's 3 over the adjacent. And take note, our adjacent in this case is given as what? As 4. So that means you're going to multiply 2 times 3 over 4, which is going to give us 3 over 2 in that case, or we can just use our calculator direct for the simplification purpose. So that is 2 in this case, right? Multiplied to 3 over 4 like that. So this is going to give us 3 over 2, or as a decimal, which is 1,5. So that is how you can have your answers as long you have a complete diagram. As long you've got a complete diagram of your information, you can be able to calculate whatever that you're given. And so, as you can see, it's important to note where you are given your values, like the interval, all right? So we have got another question that you're going to consider. This time they're saying the tan of theta on B here, the tan of theta is 5 over 12 and sine theta is greater than 0. Determined by means of a diagram these values. All right, let us interpret our information first. The tan of theta is 5 over 12. All right, so that is the second question. Is it B? All right, so they are saying the tan of theta is 5 over 12 in that case. All right, so this is 5 over 12 and sine theta is greater than 0. So at the same consideration, the sine of theta is bigger than or is greater than 0. So let us interpret this before we talk about these questions that you're asked to find 13 cos, whatever that you need. We want to interpret our diagram first. Which quadrant are we talking about? So if you check here, you are not given angles. If I am given angles, guys, we want to be honest to each other here. If let's say you are given a condition whereby you are given the angle in that case, you cannot, because you can just take direct, because you know this is 0, 90 degrees, 180 degrees, 270 degrees back to 360 degrees. So for whatever angle that you are given, you can properly see, okay, it's between 0 and 90. I can just take direct. All right, it's between 90 and 180. I use this quadrant. It's between 180 and 270. But on this case, it is not that way. All right, it's not that way. That part, or this concept that we are supposed to use, we are supposed to go back to our cast concept, all right? Or you can use all students take calculus, all right? All students take calculus, all right? Or you can just use our cast concept, the one we are used to, that is cast, but starting in the fourth quadrant, cast this way, all right? So we are going to have our cast like this, all right? So that is cast concept, cast like that. So starting from the fourth going other way. All right, so from this concept, we can now interpret, because this gives us exactly what we need to know. It gives us exactly what happens between 90 and 180 to say there it's only sine which is a positive. Between 180 and 270 in that quadrant, it's only tan which is positive. Between 270 and 360, it's only cos which is a positive. Between 0 and 90, all of these ratios, they are positive, all of them. So they are saying tan theta is 5 over 12. As we can see here, you are given a value. You are given a value there, which is 5 over 12, and it's a positive. So we can see that the tan of theta here is a positive value. So we are having a positive value for tan theta. So by having a positive value, we are in confusion right now because there are two quadrants where we can have a tan being a positive. Which quadrants? One, it is the ratio, the one where tan is found here, the quadrant for t, between 180 and what? And 27. That's where tan is a positive. Also here, because we said all of our trigonometrical ratio, all of them, meaning to say tan is a positive, cos is a positive, sine is also a positive, all of them. That is this quadrant. So now we have got two quadrants where tan is positive, this quadrant and this quadrant. So that's why they are giving us another ratio to consider, because you are supposed to know exactly where to put your triangle. So that's why you are given another ratio. They are now saying here, sine theta is greater than 0. I explained about these signs. Greater than 0, it means we are talking about positive values. Less than 0, it means you are talking about negative values on a condition of less than 0. So they are saying the sine of theta is bigger or it's greater than 0. It means the sine of theta is a positive. Once you understand this, guys, you are done, because you now go back to your quadrants now and conclude, because in this part that we're talking about, we were having two quadrants in our mind, this quadrant or this part. But now we are very sure, because here we know that sine is a negative because it's only tan which is positive. Also cos, it's a negative. So it cannot be this quadrant, because they are saying sine is greater than 0. Sine is a positive. So we need a condition where tan is given as a positive and also sine is given as a positive. Which quadrant is that? That is the first quadrant from 0 to 90. That's where we have tan being a positive and also sine being a positive. So that is the importance of knowing your quadrants. It's either you know it from given angles or you know it from this way that you are given. So as you can see, this one is a repetition of our last question, because we are still back to the first quadrant, as we concluded that it can only be positive, both can only be positive in the first quadrant. And in the first quadrant, we saw that our theta is greater than or equal to 0 degrees, all right, but less than or equal to 90 degrees. That is how this question was supposed to be given as, but they are avoiding giving us this angle presentation. They want to talk in terms of your ratios being positive, to say the ratio of tan, it's positive, the ratio of sine, it's positive. Which quadrant consists of the both ratios being positive? So we saw that it is going to be in the first quadrant, and as I indicated before, in the first quadrant, that is how we are going to have our terminal to the terminal point. That's how you present your line from or for what? For the hypotenuse in this case. All right. So as we can see, also in this quadrant, we indicated that it follows that in this first quadrant from 0 to 90 degrees, our angle theta is going to be taken this way. So this is our theta from the positive horizontal axis up to when we meet our resultant here. And that means our x is positive, our y value is a positive in that case, and this is our hypotenuse. All right, so you can fill in, and according to this theta that we are seeing here, it follows that this is the opposite. The one that is facing theta is your opposite. The one that the theta and the angle are on the 90 degrees here, they are sitting on the same line. They are found on the same line. That means that's your adjacent, and this is our hypotenuse, the one that we write as r in Cartesian plane concept. All right, and the adjacent, these are the x values. All right, so the adjacent, these are the x values, and the hypotenuse, these are the y values here, the y values, that is our opposite. All right, so let us see what we have from this ratio, guys. As you can see, it's a positive, and as we know, guys, from our soccer tour concept, the ratio of tan is opposite over the adjacent. So there we are given the tan of theta being 5 over 12. That means we've got the opposite, and we also have the adjacent, opposite over the adjacent. So you can fill in according to this theta here, as we named on our triangle. According to theta, our adjacent in this case is 12, and the opposite in this case is the one that corresponds to 5. All right, so we have got 5, which is the opposite, which is 5. So this is going to be 5, and the adjacent, which is going to be given as what? As 12. And this is our adjacent on our diagram. So we have got the x value there, which is a 12. All right, so this is going to be a 12. All right, which is our x value. So we have got the y value. We also have the x value, but we do not have the resultant, which is the hypotenuse in that case. So like I said, fill in your diagram. Remember that r squared, which is the hypotenuse squared, is equal to x squared plus y squared. So we can substitute r squared. We want to calculate r. We are given the value of x, which is 12. So that's 12 squared plus the value of y here, which is 5 squared. So that means r squared is going to be 12 squared, which is 144, plus 5 squared, which is 25 from your calculator. So you can just add these two, you obtain 169, and from there you can determine the square root of 169, which is going to be 13. And like I said, the hypotenuse cannot be a negative, so don't waste your time writing 13 plus or minus 13. And also these are just units, so you can just write 13 units or just write it as 13 as it is. So now we have got this side. We've completed our diagram by finding, by finding our hypotenuse. We have completed our diagram from the ratio that we are given. It helped us to fill in this diagram, and also the one for sine theta at this part, it helped us to know the quadrant to use, which part to use of the diagram. Is it going to be here? Is it going to be presented in this quadrant, or is it going to be presented here? That is the purpose of this statement or this whole thing that we're given there. All right, so anyways, let us check what we are being asked on this question. So the questions in this case on number 1 was to find or to determine by means of a diagram the value of 13 cos theta. All right, so you need to find the value of 13 cos theta. We now have our diagram and everything relevant that is important. All right, so the value of 13 cos theta. Remember the value of cos in this case. How are we going to take our cos? So that is 13 times cos theta. Remember that is the adjacent over the hypotenuse. So according to this theta, that is our adjacent. All right, so you're going to have adjacent, which is 12 in this case, over the hypotenuse, and our hypotenuse is 13. So that's going to be 13 times 12 over 13, which is going to be 12 in this case. All right, or you can just use your calculator to multiply the two. That is, we are going to multiply 13 times 12 over 13, like this. 12 times this, which is going to be a 12. So that means we've got the value of 13 cos theta. You're just substituting now because everything is there on your diagram. And also we are asked to find the value of cos squared theta plus sine squared theta. All right, so let us see what we are going to have for the value of cos squared theta plus sine squared theta. It's actually a very, very important trig identity that you're going to also work with mostly in our grade 11 and grade 12, that one that you are given. All right, so they are saying we must find the value of, remember, cos squared theta plus sine squared theta. All right, so let us see what's going to happen. Cos squared theta plus sine squared theta, like that. Remember what I said, for a trigonometric with a square or whatever exponent that you have here, it means the trigonometric here, you raise it to that exponent, which is 2. So this simply means I'm having the cos of theta, everything raised to the exponent of 2 like this, plus the sine of theta raised to the exponent of 2. The sine of theta as it is to the exponent of 2. So there we can substitute our values because we have our answers here. The cos of theta, remember that the cos of theta is the adjacent over the hypotenuse, adjacent over hypotenuse. So from here, we are having the adjacent, which is 12 over the hypotenuse, which is 13, which is r. So it's going to be 12 over 13, but everything has to be squared. So that is going to be squared plus the sine of theta in this case, which is the sine of theta, it's opposite over the hypotenuse. So here it's opposite over the hypotenuse, which is 5 on the opposite, and the hypotenuse being 13. So that is going to be 5 over 13 squared. So that is going to be the sine of theta squared. So as we can see here, we have to simplify, see what's going to have. Let us just see our calculator. It's a special trick. There's something that we are going to deduce at the end that we are going to talk about at the end. So this is 12 over 13. You square this plus, open a bracket, 5 over 13 like this, 5 over 13, close the bracket, square it, it is going to give us a 1. So as we can see, this whole part, it gives us a 1. So in a conclusion, there is this identity that we refer to as the Pythagorean identity, which is the initial or the first identity that actually going to talk about on the identities in our grade 11, grade 12, which is the Pythagorean identity. From the Pythagoras theorem, it follows that the cos squared of theta plus the sine squared of theta is equal to 1. Whether it is the sine of 30, I want you to take anything, the sine squared 30 degrees plus the cos squared 30 degrees like this, you are going to get a 1 as long you are given same angle, this theta, as long it is the same angle, you're going to obtain a 1. So remember what I said, cos squared 30 like that, it means cos 30 squared. You're going to square the whole of this part under cos. All right, so let us just have our calculator and show this part that I'm explaining, making sure that your calculator is in degrees. So you're going to have this, open a bracket, you're going to have this as sine 30 degrees, close that. All right, so you close this for the angle, then you close for the whole of the sine, you square it. All right, plus you do the same, open a bracket for cos, so that is cos 30 degrees like that. You close the bracket for the angle, then you close the bracket for the trig of cos, you square it, you're going to obtain a 1. So whatever part that you can have, whatever angle, as long these angles are the same, even if I put 45 degrees here, and I also put 45 degrees here, you're going to see that you're going to get a 1 always. So it's an identity that you are supposed to know this one, all right? But in our calculations, we are not supposed to actually just know that this identity gives us a 1. And if we know that, we just write an answer like this. No. In our syllabus, you are supposed to prove that or to calculate it and prove that it is going to give you a 1. But later on, as you move on to the grade 11, grade 12, you now use that identity as it is. But like I said, in our syllabus, we just apply this identity just like for the sake of revision. That is how you work with it. All right, now we are given the question C. So like I said, this interval is the one that is important for us. All right, so let us see what they're saying here. They're saying 5 cos that, that is 5 cos A is equal, 5 cos A plus 3 is equal to 0. All right, they're saying 5 cos of A plus 3 is equal to 0. All right, that is good. And from there, they are saying A is greater than 0, but greater than 180, but less than 360, right? The same A that we have here, it's greater than 180 degrees, less than 360 degrees. All right, what type of A is this one? All right, let us consider this. All right, so this is our C part. So after that, they are saying we are supposed to determine by means of a diagram, this and that, the tan, and this and that that you're given there. Okay, which is fine. But as we need first to understand this statement here, we talked about our angles, but we never saw a condition that 180 can be taken direct from 180 to 360, because you are talking about two quadrants that are being involved. Two quadrants are being involved there. So we're talking about angles here, all right? So remember, this is our x, no problem. We're gonna have 0 degrees, 90 degrees, 180 degrees, 270 degrees, back to 360 degrees. So from this part, they are saying A is greater than 180, less than 360 from 180. This is where we are given our theta to range from, the interval of our theta. So we're talking about two quadrants at the same time, this quadrant or this interval or this part. So we do not know exactly from this one that we see here. There are two parts that we can refer. It's either it's in this quadrant or it's in this quadrant. So we go back here now and see to conclude, because we are given there that 5 cos A plus 3 is equal to 0. Can we find cos A so that we can conclude what this A represents? All right, so we can just play around this transpose, make cos A the subject. So that's 5 cos A is equal to, transpose this to the other side, it becomes a negative 3. Divide by 5, divide by 5, that means the cosine of A is equal to minus 3 over 5. So we now have the cos of A as a proper fraction that we can conclude to see where our cos is a negative. So this one, we are back to the cast concept because it's not an angle there. It's a fraction, so you have to know where cos is negative. So you're going back to your cast concept, all right? So from our cast concept, we can see that our cos is a negative, all right? In which quadrant? In this quadrant and this quadrant, because all is for all the ratios, they are positive. Here, cos is positive, but in this quadrant, it's sine, which is positive. So meaning to say cos there is a negative. Here, it's tan, which is positive, and cos there is a negative. So as a final conclusion, we can conclude that the quadrant or the region where this A is going to lie, it is going to lie in this quadrant, which satisfies both conditions. It is not supposed to satisfy only one condition. No, it is supposed to satisfy both conditions that you're given. The first condition, that our A is greater than or equal to 180, greater than 180, but less than 360. And we saw that we've got two regions to consider, this region or this region. Now we are saying cos is negative. We have got this region and we've got this region. Where do we have a condition that is being satisfied by both, where cos is negative and also our angle is in between 180 and 360? We are going to see it satisfied in this quadrant, that is from 180 to 270 degrees. So in actual sense, they were just supposed to tell us that our quadrant or the angle that we are using there is between 180 degrees and what? And 270 degrees. So by you can now present, because you now know that this is going to be in this quadrant. So we can present this as a final part. All right, just gonna take this quadrant like this. We have concluded, we're gonna find this here. So in this part, having our cos, remember from our SOHCAHTOA concept, we talked about this from our SOHCAHTOA concept. We said cos is going to be given as the adjacent over the hypotenuse. So according to this ratio, the cosine of theta is the adjacent. As we can see, it's in the negative, and the hypotenuse, we're going to take this way. That is something like this, all right? Taken from the positive, going this way up to where we meet this line. This is the angle that we are referring to as our A in this case. But having our A, we are going to use the angle that is inside the triangle to relate our ratios inside. So according to this angle here, we said cos, it's adjacent. So this is adjacent over the hypotenuse. So it means I'm having the adjacent according to this angle inside. This is our adjacent. So we've got our adjacent here, where we have got our angle and 90 degrees. They are on the same line. I think I talked about these guys from our triangles from the beginning. So that's our adjacent. And this being our opposite, the one that is facing this angle here. So that is your opposite in this case, and this being our hypotenuse, which is R. So we are given the adjacent, which is -3. That's true because our x there is a negative to this side. So meaning to say our x is given there as a -3, and the hypotenuse, which is R in this case, is given as a +5. So as we can see, what is missing on our diagram is the value of y in this case, which is representing our opposite. So that's where now we can use our Pythagoras theorem because we've got two sides and want to use them to find the third side, which is the opposite. And according to the y values down here, I said these values, they are taken as what? As negative values. So meaning to say we are going to have our answer as a negative in that section. We are going to have our answer as negative values in this section down here. So let us use our Pythagoras theorem and see what we are going to have at the end. So from our Pythagoras theorem said r squared is equal to x squared plus y squared. We've got x and y there. So r being 5, so that is going to be 5 squared is equal to x, which is -3. So you're going to have -3 squared plus y squared, which is the one that you're supposed to calculate. These are the y values. So we do not have this value here. All right, so 5 squared, that is 25, is equal to -3 squared. That's a +9. Remember, negative and negative gives us a positive when you square it, or you can just use your calculator direct. Here, let us just see. We're going to have -3 squared. Just open your bracket, -3, then you close it, you square that. That will be a +9 in that case. All right, so this will give us a +9 plus y squared. So we can transpose this 9 to the other side so that it becomes a positive. So that's 25 minus, it becomes a negative, sorry, on this side. So 25 minus 9 is equal to y squared, which is going to give us a 16 if we subtract. So that means we can determine the value of y by inserting our square root. In this case, y is going to be plus or minus a 4, the square root of 16, which is plus or minus 4. But as I said, because you are considering a Cartesian plane, you need to know, or you need to work with a position where y, or with y there, the position where y is located, it is up below the x-axis here, it is down. So all values that are down here, we are going to take them as negative values. So those values will be negative. So meaning to say our y value is going to be therefore taken as a -4, not a positive, but a negative. So we are going to have our y value here as a negative. So y in this case is going to be given as a -4. You are going to take that value wherever you use it, you are going to use it as a negative. That's how you play around your information. So we have the diagram. It's now complete. Let us see our questions. So the two questions that we are given, the first one is tan squared theta in that case, all right? So that is tan squared theta. So in this case, all right, is 8. All right, that's tan squared A, that is A. I'm wondering where am I having theta because we've got A in this case, all right? So that is tan squared A. Remember that the tan squared A means we are simply squaring the tan that we are given. We are simply taking the value of tan, we square it. That's what I said before. That's you're simply taking this tan A, you square it. So it simply means I have the tan of A, but everything I have to square that value. All right. So let us go back to our tan from our ratio is opposite over the adjacent. So according to this A, like I said, yes, you are referring to this as your A in terms of the angle, but in terms of the answer, you take it from the one that is inside this angle, inside of the triangle, this one. So that is the one that you refer to from your ratio of what? opposite over the adjacent. You refer to this angle inside. So this is our opposite, which is -4 in this case. We're going to have opposite, which is -4 over the adjacent, our adjacent, which is -3 in that case. So that is over -3 to the exponent of 2. All right, so that means we can simplify this direct. This simply means we've got 4/3 to the exponent of what? 2, which is going to give us 16/9. Or you can just use your calculator direct. That means we have got the tan of A direct, all right? The tan squared A, which is going to give us 16/9 in that case. All right, let us figure out the next question and how are we supposed to answer the next question from the same diagram that we are given. Now they want us to find the value of sine A over the cosine of A. So the value of sine A over cosine of A again can be found from our ratios direct. So the sine of A over the cosine of A means we are going to apply our ratios. Remember, sine is opposite over the hypotenuse, but like I said, you take according to the angle inside of the triangle, this one. So according to this, what is our opposite in this case? What is our hypotenuse? Because we've got opposite over hypotenuse. So according to this angle, this is our opposite, which is -4 over the hypotenuse, which is 5. That's the positive. So hypotenuse, where is it located? Always hypotenuse, I said, it's a positive. Does not matter about you have it down here or you have it on top here. The hypotenuse is always a positive, right? Then we move on to the cos of A in this case, which is adjacent over the hypotenuse. So we're going to divide to the adjacent. This is our adjacent, which is -3 in this case, all right, over the hypotenuse in this case, which is a 5, all right? So we're going to have this as a 5. So that is how we're supposed to have this, or you can simplify to say this is simply tan theta, but there we are supposed to have it like original from the basics where it actually taken from, right? So as we know, guys, if you are back to your division, whenever you are dividing, this is simply a fraction divided to a fraction. So that's a division line that you have. So it's this fraction divided to this fraction. So what do? You simply introduce a multiplication on this division. So it is going to be -4/5 multiplied to, the moment you multiply, you interchange these two here. So you're going to interchange this on top and this down. So it's going to be 5/3. So it's going to be 5/3 like that. So as you can see, this will cancel, this will cancel. You're going to remain with 4/3, or you can just use your calculator direct to simplify this value here. Just have your fraction like this, open a bracket, write -4/5, all right, -4/5 like this, close the bracket, divide 2, open a bracket, that's -3/5 like that, all right? Then you can close your bracket like this. You're going to obtain 4/3. So this is the same answer that we are having at the end, which you can also simplify direct without just applying your calculator, but by applying your normal calculations of fractions, where you introduce the multiplication and you interchange the second fraction as given. So this is the idea that you are going to be focusing with. There are different questions that you are going to be given, so many questions that you need to work on, and some also on the simplification of finding even the unknown values. And also you're going to see that all you just need is to work with more question papers. It can be very, very helpful if you revise from your question papers. That can be very, very helpful to see how do they ask these questions, because we've got the same meaning or the same interpretation. This E that we are having here, it is the same scenario again, just like the previous case that we had, but now the quadrants, the issue is, guys, know where to locate your angle. Where is your angle located? All right, so let us try to interpret with this one and see. We are given that 13 cos theta. All right, let me just do this. All right, so that is 13 cos theta minus 5 is equal to 0 and theta is greater than or equal to 180 but less than or equal to 360 degrees. Theta is taken from 180 to 360. Again, it is similar, but you're going to see because of this part here, it is going to be a different quadrant. So it's 13 cos theta minus 5. All right, that is 13. The cosine of theta minus 5 is equal to 0, like that. All right. Then we also have our theta from 180 to 360. So our theta is taken from 180 degrees to 360 degrees. All right, so let us just try to interpret before we come back to the questions. We're going to see that it just familiar to this question that we had on this C. So I want you to try this D here and see if you are together. But if you've got questions on that, if you fail to obtain these values, let me know so that we can work on it together. All right, so like I said, this is a familiar question, but let us just check where are we going to have our final answer at the end. All right, so let us just simplify this cos and see what we're going to have at the end from our cos theta. So it is going to follow that we're going to have the cosine of theta transpose of -5 to that side. It is going to be a +5 in that case, all right? So we can divide by 13 here. That means the cosine of theta is going to be given as 5/13. And remember, here it gives us or it tells us where our cos or the ratio is going to be taken. Where are we going to take this cos to be a positive? We go back to the cast concept so that you can figure out with your Cartesian plan. All right. Then here we are given from 180 to 360. Also, we have to figure out from our Cartesian plan where our theta is greater than 180 in the interval of 180 to 360 degrees, I mean. All right, so let us see what you're going to have at the end if we apply this concept. So you're going to have something of this nature. All right, so remember our x and y values on our Cartesian plan. And let us start here. They are saying the cosine of theta here is 5/12 from our calculation that we made. We saw that it is going to be 5/12, which is a positive value. So this is a positive. So we need the quadrant where cos is a positive. So from our cast concept, we are going to see that cos is a positive here in this quadrant. All right. And also here for all, remember A is for all. So our cos is positive here and also positive here. So there are two quadrants. We are now in confusion. Which quadrant is it that I'm going to take? You are now in confusion there. So what I'm going to do, you are now going back to this part that you're given here. They are saying our theta is going to be taken from 180 to 360. This is 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. So in between 180 and 360, we are going to see that we are starting from this point, 180 to 360 degrees. That is where we are going to have our final answer. So there are two quadrants which are being involved here. We are talking about this section of T and also this section of cos. So where are we going to have our final answer? We need a condition which satisfies both conditions. The first condition, that cos is a positive, which is the first quadrant and the fourth quadrant. The second condition of our angle, where is our angle located? So you can see that where both conditions are being satisfied is this quadrant, where cos here is in between this angle that we are given, and also cos is a positive. So we are going to work with in between 270 to 360. This is the quadrant that we are going to use. So this one, we are not going to focus on this, right? We are not going to focus on this part here. We are also not going to focus on this. We are going to be left only with this section. That is where both conditions are being satisfied. So from there, we can have our diagram as now we have our conditions that are being satisfied. We can complete our diagram now. All right, so like I said, we are going to focus with this quadrant. All right, so let me just draw properly here. So we are going to have, remember, we're going to have this and the theta being taken as the angle from the positive up to the line that we have this one. That is going to be your theta in this case. But in calculations, you use the angle that is inside the diagram, which is referred as the reference angle, this one. This is the one that you're going to use to find the ratios or to insert your ratios according to the sides that is opposite or adjacent or hypotenuse. You are going to be using this angle that is inside. So as we can see, according to this angle, this is our opposite side, which is the value of y, which is negative. As we are down below the x-axis, it's a negative. All right. This is, according to this angle, and 90 degrees. They are sitting together on this line. So this is our adjacent, which is the x values, and the hypotenuse, which is always facing the 90 degrees, which is our longest side. So according to this course, remember from our soccer tour concept, cos is adjacent over the hypotenuse. So that means here we are given the ratio of the adjacent over the hypotenuse in this case. That is what you're given. And this is our adjacent. And on this side, our adjacent, which is the x values, they are positive on this side. So meaning to say this value is going to be positive as it is, which is 5, as you can see. Then the hypotenuse, like I always said, it's always a positive. So our hypotenuse, which is r in this case, is equal to 18. All right, this is the x value, which is 5. All right, we are going to find the y value, which is our opposite. So how are we going to do that? We are going back to our Pythagoras theorem, or the use of the Pythagoras theorem. Remember, we said when given two sides, you can use them to calculate the third side. It follows that the hypotenuse, which is r squared, is equal to the two sides that you're given, which is x and y squared. So it's x squared plus y squared. So that is our hypotenuse there, which is 18. Is going to be squared is equal to x squared. We have the x value, which is 5 in this case. So that's 5 squared plus the y value we do not have. That is the one that you're supposed to calculate. So we can transpose or manipulate y to be the subject, or you can find 13 squared on your calculator, which is 169, is equal to 5 squared, which is 25 plus y squared. So we can transpose 25 to the other side so that it can be a negative on that side. So we can simply subtract the two values in that case. All right, so that will be 169 minus 25 like this, which is 144. So that's 144 is equal to y squared. So to find the value of y, we are going to need the square root of our value that we are given, the square root of 144, which is going to give us two possible answers. So we need the square root of the answer that we had, which is 12, but that's a plus or minus 12. So like I said, for the side that you're given in terms of x and in terms of y, it can be a positive, it can be a negative. So you now have to locate exactly your answer. Is it a positive or a negative? How do you check? You are below the x-axis. These are the y values. So like I said, for the y values below the x-axis, these y values here, they are negative. You compare them according to the x-axis. Above, it's positive. Below, it's negative. All right. So this, we are going to take a negative answer. So that is a negative 12 on this part. Once you have a completed diagram like what we have, you can use this to find whatever that you're given on your question. So they are asking us to calculate the value of sine squared theta plus cos squared theta in that case. All right. So that is the first question, sine squared theta plus cos squared theta. So let us see. But remember what I said, sine squared theta plus cos squared theta should give us a 1. But we are supposed to prove that from our diagram that we are going to get, or that we are going to obtain a 1 in that case. All right. So let us see. The sine squared of theta plus the cos squared of theta. Remember we said when a trig is being squared, or when there's an exponent, it means it's that trig being raised to that exponent. So it's sine theta squared plus also cos theta here being squared. So it's cosine of theta, everything being squared like that. All right, so you can substitute our values according to what we are given, and according to our ratios, the sine of theta is opposite over the hypotenuse. So here the sine of theta, which is the opposite, that is negative 12 over the hypotenuse in this case, which is 13. So that is going to be 13 like this. You square this plus cos theta squared, and according to cos theta already, that is the one that we're given, cos theta. We're already having this, which is 5 over 13. So we are not going to do another repetition, but you can do that. Go back to your diagram. Still, you're going to have the same answer for the ratio of cos theta. So we are going to just use our calculator at once to simplify this and see what you're going to have at the end. So that is open a bracket, that's negative 12 over 13 squared in this case plus 5 over 12 in this case squared. So that's 5 over 12 like this. You're going to square this and you're going to see that you're going to obtain all right, 5 over 13, not a 12. This is 5 over 13, not a 12. This is 5 over 13 there. So this is going to give us directly a 1. So you're supposed to get a 1. So if you know these identities now, it will be very, very important to cross-check your solutions and see if on a condition that you've obtained a wrong answer, you can go back and recalculate that value if you understand this. All right, then the second question was 25 tan squared theta. All right, so we've got 25 tan squared theta in that case. All right, so let us see what you're gonna have here. 25 tan squared theta. So like I said, the squared there means we've got the tan of theta squared. All right, so it means we've got 25 multiplied to the tan of theta being squared like that. All right, so that means we can simply substitute our information, the tan of theta from our trigonometrical ratio, it's opposite over the adjacent. So you're going to have opposite over the adjacent in that case, which is according to this angle inside of our triangle, the opposite side is negative 12. So that is going to be negative 12 over the adjacent, which is 5 in this case, right? Our adjacent, that is a 5. So it is going to be 5 squared like that. All right, you can use your calculator at once, or you can square this on your calculator. You are going to obtain 144 over 25. All right, this is same as over 1. So if you multiply, this will cancel. You remain with 144 over 1, which is going to give us 144, or you can just use your calculator at once. You are going to obtain the same answer, which is 144 in that case. All right, so this is how your trigonometrical ratios can be applied. All you just need is to understand which quadrant are you given and simplify properly whatever question that you are given in your simplification. All right, let us see what are they talking about on question number 18, on question number H, whereby we are given in the diagram alongside the tan of theta. We are given the diagram here. This is our theta. All right, and the tan of theta, remember from our SOHCAHTOA concept, the tan of theta, which is being opposite over the adjacent in that case. So here we are given the tan of theta being 12 over 5. So that is 12 over 5, which simply means we've got opposite over the adjacent. And according to this here, we are going to see according to theta, this is our opposite and this is our adjacent. All right. So that means we are given the opposite side, which is corresponding opposite, which is 12. All right. So the opposite here is 12. The adjacent, which is corresponding value, which is 5 in that case. All right. So the adjacent, which is 5. All right. So this is actually the x value, which is 5. And this 12 is actually the y value. As we can see here, guys, this is our y value, which is equal to 5. So we've got the x value, we've got the y value like that, all right? So the question the question given here is, all right, that's a 12. Where am I getting the 5? All right, here I wrote a 12 properly. Now I'm writing a 5. This is a 12, guys. All right. Okay, so the question in mind is the point B is given here. This is our point B, which is, the point P, which is given as B18. Determine the value of B without using a calculator. All right. This is an interesting question actually that we have here because according to this, we know that this point, all right, we've got the point B and we want to find the value of B in this case. All right. We actually know that according to this point that we are given, which is P, it must represent the value of X and the value of Y in that case, where the value of X we have, which is 5, and the value of Y there we have, which is a 12. We have these values 5 and 12. But there they gave us another condition where this is now given as a B and this is given as 18, which is not corresponding to what we are given. It's supposed to be 5, 12. Now it's B18, which is the X value, the Y value. All right, so I just have to go back to my ratios to say, all right, if I am to write this ratio, because there I'm given the X value as a B and the Y value, I'm given it as 18, which is this part. I'm given this as 18 and this I'm given as B. All right, from the same ratio that I had of the tan, this one, I'm given the tan of theta, all right, before, which gave us these values that we have on our calculator. We saw that the tan of theta was given from the opposite over the adjacent, it was given as 12 over 5. So what you are going to do is that you are going to also find the tan of theta with the values that you are given now, because instead we were supposed to have it as 12, but instead of us having 12 there, they are putting 18, not 12. So we want to find tan theta in terms of these values they gave us. That is B and 18. So the opposite is going to be 18, the adjacent, which is going to be a B in that case. So this is according to what they gave us on the diagram. This is tan theta according to the exact information they gave us before here, that tan theta is 12 over 5. But these both tan thetas that we are talking about here, they are representing the same theta, this angle here. We are talking about the same angle theta. So there is no way we are going to have this tan theta giving us a different answer to this one. There is no way that these two will be different. So what it means is that also the ratios, because this tan theta and this tan theta, they are the same, they are equal, they are the same. So if they are the same, it also means their corresponding ratios should be equal. So it means the 12 over 5 in this case must be equal to this ratio that I'm having here, which is 18 over B. So I can be able to calculate the value of B from there. Remember from our equations, guys, how do you solve equations when given a fraction? Two fractions, one on the left, the other one on the right. You can easily solve by cross multiplying. So this will multiply this side, this will multiply this side. So it means I'm going to multiply 12 times B, or B times 12, which is 12B is equal to, I multiply 5 and 18. So it's 5 times 18 on the other side. All right, so that means I can be able to find the value of B if I multiply 5 and 18 in this case. All right, let us put back our calculator so that we can be on the same page or understand each other. So that's 5 times 18 in this case, like this. All right, and this is going to give us 90. So we are going to obtain 90 to find B. Simply divide by 12. By 12 in this case, you are going to obtain the exact value of B, which is 12 90 divided by 12, which is going to be 15 over 2. So our B is 15 over 2, or it's 7,5. So meaning to say, where we are seeing the B, the value that is there is 7,5. That is this B here. So it was just a tricky question. if you don't understand this ratio concept, to say there is no way that tan theta can be different, while we are talking about the same theta, the same angle. It can't be having different answers. There will be same answers. So from the concept that they are the same answers, you can equate the answers that you are given. So that is what you are given. So I want you to find as many questions, do as many questions as you can. Maybe you can just try the last one together, but try to do as many questions as you can. There on the last question, they are saying, if the tan of theta is a over b, so we are given that the tan of theta is given as a over b, where theta is an element of values from 0 to 90. So that is how also the interval might be given. The interval might be given in terms of that nature, to say it is starting from 0, ending at what? Ending at 90 degrees, from 0 to 90 degrees. Take note, from 0 to 90. So meaning to say we are talking about the first quadrant in that case, all right? That is from 0 degrees to 90 degrees. We are in the first quadrant, all right? So that is what you're going to have at the end. Going to have our theta here in the first quadrant. Remember, that's where we have our theta, our 90 degrees. This, according to theta, is our opposite. According to theta, here theta and 90 are on the same line. This is our adjacent, and this is our hypotenuse. So there, it is a direct question. So they are saying, determine sine squared theta by means of a diagram. So we are given tan theta, and we know that from our SOHCAHTOA concept, the tan is opposite over the adjacent. So we've got opposite here over the adjacent. That means A and B, they represent opposite and also the adjacent, right? That is your A and B. So this is our opposite, which is the y value that we are given. So we are given the y value definitely there, that y is equal to a. So y is represented by a. The adjacent, which are the x values. So remember, this is x and this is y. So the x values there, we are given it as b. That is our adjacent, and it's a positive. But the question needs us to find the value of sine squared theta. There is no way we can have the sine theta, because we need the opposite over the hypotenuse from the ratio of sine theta opposite over the hypotenuse. So we are going to need the hypotenuse, which is r in this case. And remember what I said about r, we said r squared is equal to x squared plus y squared. That means r squared is equal to the x value, which we are given this time as b. So that is going to be b squared plus the y value, which this time we are given as a. So that is going to be a squared. So to find r, we are simply going to introduce the square root. So that's r is equal to the square root of b squared plus a squared. Remember, a plus b, guys, is same as b plus a. So when you say b squared plus a squared is same as a squared plus b squared. So that means we have got our r in this case on this part, which is equal to the square root of a squared plus b squared, all right? So having this in mind, we can now be able to calculate the ratio of sine theta, sine squared theta. Like I said, sine squared theta means we have got the sine of theta being squared. So we are going to have the sine of theta, which is opposite over the hypotenuse. So we are going to need, remember, this is our opposite, which is a in this case. So we're going to have the opposite over the hypotenuse, but you're going to square that, which is our opposite. It's a, which is the y value. So that is a over the hypotenuse, which is this part here of r, which is the square root of a squared plus b squared, like that. But this whole part is supposed to be squared. So we are going to square everything that we have. So that is going to give us sine squared theta. All right, so that means the value for sine squared theta is going to be what? Sine squared theta is going to be given. Remember, guys, what I said. If you are dealing with exponents, because they've got an exponent here affecting everything inside, so it is going to affect here to this a. So it's going to be a raised to the exponent of 2, a to the exponent of 1 to the exponent of 2, means you multiply your exponents. So that's a to the exponent of 1 times 2, which is a to the exponent of 2. Then here there is a square root raised to the exponent of 2. This square here, it affects everything. It also affects the square root. Remember, always on a condition where there's a square root, maybe it's square root of x squared, then we square. We remain with this x squared, or maybe it's the square root of x squared, like that. Where there's a square root and a square, you simply remove the square root, you remain with the term under the square root. So there we are given a square root and a square in this case, which is the square root of a squared plus b squared being squared. So the square, it neutralizes, or it takes rid of the square root. So meaning to say, you are going to be left with a squared plus b squared under the denominator in this case. All right, so that is going to be a squared plus b squared, and this cannot be simplified further. All we can just do is to rewrite, to just leave our answer in this manner, that is our sine squared is equal to a squared over a squared plus b. So like I said, guys, there are so many ways to tackle these questions, and there are so many questions that you can find on trigonometry of this typical approach of our Cartesian plane, working on the diagram to determine whatever ratio from another ratio. So let us try to work with more question papers. Just revise also from your textbooks. You're going to see that they are going to just have a repetition throughout. As you are revising, you're going to see a repetition of questions throughout. But just try the questions that we did not work on them together. Just try to work on them. And if there is a question, let me know, guys, on the comment section, so that we can work with those questions together. We can have a redo of the video on the question that you still have a challenge on these questions. But I hope with this idea, you can be able to tackle any question that you might be given. So just also put more practice. Mathematics is all about the practice that you put in through.